Hi guys, welcome back to another video. This is Codeforces Round 846 due to, and the problem is GCD Partition. Let's see what the problem states. So while at Kira's house, Josuka saw a piece of paper. These are all just stories. So let's quickly go through the problem. The task sounds as follows. There is an array A of length n. So let's say we have an array A. Maybe those are integers that is given in the constraints of length is n. Okay. On this array, we do the following. Select an integer k greater than 1. So let's try to select a number k, that is k can be at least 2, right? So let's take 2. Okay, k value is 2. Split the array into k subsegments. Subsegment means a continuous set of numbers is called a subsegment from start to end. So since we took k as 2 here, the subsegment will be something like this or anything. If k value is 3, we take 1, 2, 3 like that. So for now, we take k value as 2. Now, what else did they ask? Calculate the sum of each of k subsegments and write these sums into another array B. So we took these subsegments, we have to calculate the sum. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 5 is 12. So this is copied into another array called B. And now they are telling that the final score of such a split will be GCD of B1, B2 up till BK. B1, B2 is nothing but this one, 3 and 12. Now they are telling that the GCD of B1 and B2, that is 3, 12, is the score of this operation. Now, so what did we do? We took a k, we split it into k subsegments of A, we took the sum of each of the k subsegment, then took all the numbers and put it inside the GCD function. The GCD function gave a number and that is called the score. And our task is to find a partition such that the score is maximum possible. We got 3, but it may be 30 or 12 or it can be much more. That's what they are telling. It can be anything. Now Josuka is interested. We have to find the maximum possible score. They are just telling like what is a k subsegment and what is a GCD about. So that's the overall problem. So to understand this further, without going into the solution first, let's quickly do some trial and error with the given examples in the question. So these are the examples that they gave, that is 2, 2, 1, 3. So let's suppose this is n value, okay, this is test cases. So this is the A array. So we have 2, 2, 1, 3. Let's suppose k value as 2 here. What do we do? 2, 2, 1, 3. Maybe 2 we can take here and 2, 1, 3 we can take. What is the sum? 2, 3, 4, 5, 6. What is the GCD of 2 and 6? It is 2. Okay, maybe we can try some more things. That is, maybe we can split here. That is 2 plus 2 is 4, 1 plus 3 is also 4, 4 and 4. What is the GCD? It is 4. So ideally, like we have already reached it, but let's take one more example like 2, 2, 1, 3. We can take now k as 3. 3 means somewhere like this, this, this. Now 4, 1, 3, GCD is 1. So we got the highest value, that is 4. I hope you got the method on what exactly we need to do. Now let's take the k value again, that is 1 and 2. We have to take at least 2 here, so we need to split here, that is GCD is 1. Now 1, 4, 5. Randomly again I am taking k value as 2. It may or may not be 2, but let's take this 1 plus 4 and 5. So 5 can come, 1 plus 4 is 5. GCD of both of them is 5. So we got like this. Now this is an interesting example here, 1, 2, 1, 1, 3. So let's trace it out, 1, 2, 1, 1, 3. So for now let's take k value as 2 here and take 1 everything. 1 here, 2, 3, 5, 6, 7, 8. No, here 1 is the GCD. And maybe how about let's take something like this, 2, 3, 4, 3, 4, 5. Again GCD is 1. So probably let's try to make k value as 3 or something. These are all random. We did not go to the solution yet. So we took like 1, 2, 1, 1, 1, 3. We took 1, 2, 1, 1, 1, 3. What is this? 1 plus 2, 3. 1, 1, 3, 3. Okay, so now the GCD value is 3. That is the solution here. If you try any other method, it won't happen. This is the maximum possible. So for k equal to 3, for splitting the subsegment like this, we got 3. And for 7, 7, 7, 7, 7, 7. This is the last example. Let's try that. 7, 7, 7, 7. It can be many methods, right? You can split here, split here, split here. If you do k as 3, you can get 14, 14, 14. The GCD is 14. But the better way, what they are telling is, you just take k value as 2 and split it straight in the middle. This is 21, this is 21. GCD is 21. This is k value as 3. So we got this with the help of trial and error. Now we have to come up with a solution. So what is GCD? GCD is the highest common factor. So if you see, if we are splitting something into a set of intervals and calculating the sum, we are getting a factor, right? So that means what? 14 can be written as 7 into 2, right? This also can be written as 7 into 2, and this also can be written as 7 into 2. What if I tell you, instead of taking all the subsegments, so suppose it may be cases that we may think something like, okay, let's block here, let's take this one, and let's take all the possible combinations here. This can come here or this can come here. Then again, if I remove this one, it can be like this one, and take everything. But the calculation will be so huge, there will be like 2 per n possibilities. It's not gonna happen. So what if I say that instead of k equal to 3, can I make k equal to 2 always? That is correct, because if I came to know that 7 is the common factor for 2 subsegments, 7 is the common factor for 2 subsegments, I can merge these together, right? If I merge these together, what is this? 14 and 14, that is 28. Still 7 is a factor here. I am not destroying this 7 anywhere. Even if I merge this, 7 will be the common factor. So suppose 6 and 1 comes, 6 plus 1 is 7. If I combine this also, the 7 factor still remains. Only the multiple x will be scaled, but the common factor still remains. So that's what I'm trying to say here. So instead of 1 2 1 1 1 3 here, what if I merge these two together? 3 4 5 6, right? 6 can be written as 2 into 3. 3 is here, 3 is there. So the highest common factor, the common divisor, still lies for all. So for all k equal to 2, we can find this approach. Now let's come, how are we gonna solve it? Now we came to know that we can do with all k equal to 2. Now which will be the ideal split? Here also we can split, or here also we can split, anywhere we can split, right? So we just iterate through it only once. Now how can we do it? We have to know the sum. So they are telling that if the B array is there, the subsegments are the sum of the elements. If we want to know the sum of the elements, we use the most common method to know, and I hope you also will know it, and that is something called as prefix sum. So how do we calculate prefix sum here? 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 3 is 9. Hope that's clear. Now the sum of all the elements is the prefix sum's last number, that is sum equal to 9. Now next task, we have already understood that k equal to 2. Now the next task is we need to know the ideal split. So we have to iterate through all the possible combinations. So first let's keep 1 as static here, and the sum till here. What is this? The sum till here is total sum minus this number, that is 8. So this is one subsegment, and we take numbers till here. Okay, this is the interval now. So sum till here is 3. If you want to know the balance, that is 9. This is 9 minus 3, 8, 7, 6. This is also one interval. And now again we do the same thing. We go till here, and what is this sum? 1 plus 2, 3, 4. That is what we have written. 4, 9 minus 4 is 5. 9 minus 4 is nothing but the sum of these elements. So it is 1, and so on you can do. Now we have to find the GCD of all these numbers. We got all the possible combinations. We find the GCD here. This is 1 here, GCD is 3 here, GCD is 1 here, and so on. Now inside this function, we have iterated all through this. Now we have to find the GCD. We have to get the max GCD out of the given GCD. From this we have got that we got as 3. Now even if you iterate through everything, 3 will be the highest value. I am not stopping here, but you have to iterate through it, so that we can see with the help of an example. So for the coding part, I'll show you this one. So this is the accepted solution here. I'll explain as well. So we are taking all the integers in the array, that is v of I is the vector where I'm storing all the a array. Now we are taking the prefix sum. How are we taking the prefix sum? First number is stored in the prefix, then from I equal to 1 to n, the previous element we are keep on adding it as sum. Now as I told you, prefix of n minus 1, we are assigning it to sum. Now let me quickly go to my board and explain you. So this is the board, and let me try to take the same example, that is this. What is this is B array, and prefix of 0 is the same number, that is 7, and 1 to n. I am iterating through this one to n minus 1 here, and prefix of I is v of I. What is v of I? V of I is v of 1 plus prefix of I minus 1, 7. 7 plus 7, 14. Okay, 14 plus 7, 21, 28, 35, and similarly so on. Now we got the prefix array. Now what I'm doing is I'm taking a value called as sum. Sum is the total sum, that is here 42. Okay. Now I am iterating through I equal to 0 to I equal to n minus 2, because till this I am splitting into k subsegments. Now GCD of pre of I comma sum of pre of I. What is pre of I here? 7 comma sum. What did we get? 42. What is 42 minus 7? It is 35. Now GCD of both of them is 7, and max GCD is currently 7. Okay, because this is the first value. Now we go to the next element, that is I equal to 1. We take prefix as value as 14, and 42 minus 14 will be 28. So now we just have to tell the GCD of it. This is 14. Max GCD will be converted to 14. Again, you iterate. Now let's take to the V of 2. That is 21. We take 21 here, comma. What is 42 minus 21? That is 21 again, right? This is 21. Now GCD will be 21 again. Now similarly it will go on. So that's the logic. We got the maximum GCD as 21. So we take so again the k value, we assumed that if we merge the subsegments, the common factor still remains, and k value can be 2 here. And what we are doing is we are taking the prefix sum, and from the prefix sum we are going to find the ideal interval where k can be split. So for that we are just taking all the possible combinations in a sequence, that is from 0 to n minus 1. Then from that we are taking the common divisor, we are taking the maximum GCD. So that's it, and let me know if you have any questions. You can refer to this solution. Thank you.